It's great to be here in person. This is my first chance in presenting what I think is a potentially game-changing application and a company that has the ability to scale and address a transformational market. We all believe that the energy transition needs to happen by 2050, but in order for that to be a reality, photovoltaics will have to deliver at least 9 terawatts of installed capacity. President Biden just said that 50% of the electricity in the US needs to come from solar. But currently, the limitation is not only scale, it's the efficiency of those systems. Current technology is at 22% efficiency, and all of the economies of scale in China have essentially been petered out. The levelized cost of electricity is plateauing. So, Nexwafe, the company that I am representing, with green solar wafers, will change this paradigm by taking us from 22% to up to 30% efficiency over the next 5 to 7 years. And the way we're doing that is by being able to create tailored solar wafers that actually consume only 1/4 of the carbon emissions, or give 1/4 of the carbon emissions, and consume half of the power. The reason they do that is that rather than using the conventional process of first melting silicon and then creating an ingot that has to be sliced, it's a direct gas-to-product process. That means that you can tailor every single wafer to be identical to the previous one. You can make them ultra-thin as 90 to 100 microns. And why is this important? Because new cell processes that are now being developed, such as heterojunction technology, no longer have their peak efficiency at 150 microns, but they much more efficiently capture solar radiation, so their optimal thickness is as thin as 90 microns. But using wire sawing on traditional ingots cannot achieve that particular metric. So by using a simple process of taking a seed wafer, then making a clone of it through this gas phase epitaxy, and then mechanically separating it, you're able to, in fact, create a permanent cost advantage to current technology. Now, to build on what Bart and Robert were talking about, we are not going to be doing this alone. In fact, we intend to partner with scale-up companies that are interested in developing large-scale facilities. For every 15 gigawatt plant that is established, we will be able to avoid the emission of 4 million tons of carbon dioxide every year. So a 15 gigawatt plant is, of course, very large, but it's only 7% of the market in 2028. So one such factory will, in fact, be the equivalent of eliminating 900,000 conventional passenger cars. So it has the impact twice of what Tesla had last year in delivering CO2 savings. The final goal is not only to produce something that is more cost-effective and more energy efficient, it's also to produce the optimal solar wafer. Nirvana is actually to be able to tailor the material properties such that you actually have a gradient of doping, so you can go beyond the conventional limits of 24 to 26%. Up to now, the only way to do that is to create 2 solar cells on top of each other, what people call tandem technology, either using perovskites or other materials in addition to silicon. Because our process doesn't use quartz crucibles that are a source of oxygen, that means our material properties allow us to be able to tailor an ideal wafer that can already, by 2026, achieve 26%. Not only that, we can start introducing material variations such as germanium quantum wells into the structure that, according to our studies, will allow us to achieve 30% by the end of the decade. So even though our first product is a drop-in replacement, over the next 5 to 7 years, we have the chance to revolutionize solar and make it truly the most efficient, cost-effective form of renewables. Now, what does this mean for our investors? For our partners who build large-scale facilities, it means internal rates of return, irregardless of location globally, of over 40% when at scale, and gross margins of 65%. This means that we have essentially a licensing model. We do believe that in the pilot facility, where we already have a site at Bitterfeld, Germany available for us, we will have significant ownership to be able to show scalability. But from then on, we already have strategic partners that have shared their intent to not only have offtake from that pilot facility, but to join us on the journey to gigawatt scale. And that means in other locations, North America, Asia, as well as certain locations in Europe, you will be able to establish production capacities that will be able to transform the industry. This means that our revenue model really almost looks like a software model. By 2023, we will already have contracted that a large-scale facility will start producing in 2027. So the time to certainty about the success of this technology is only 24 to 36 months away. That's why now is the time to invest, because as we prepare the plans for the pilot scale, we already are locking in long-term contracts with strategic partners that will allow the technology of diffusion to be efficient. By 2028, we will already be returning 200 million euros in cash flow to the business. So, where are we today? We're doing a Series C, and we're in deep conversations with strategic partners for both offtake agreements, gigawatt scale, and investment in the round. By 2023, we expect to finish the complete funding of the company with an additional Series D, and then be both profitable and have exit within the next 5 years. So I hope you will join us on our journey, and I'm eager to share with you more details of the technology after this presentation. Thank you very much, Jan.